this isn't a history class, okay? This is a chemistry class. So I'm going to talk a little bit about the chemistry behind cell phones. There are 83 stable elements on the periodic table. And of those 83 stable elements, 70 of them can be found in your cell phone. That's 84% of all stable elements. That's a lot of elements. And we use so many because they have different properties that we can utilize to bend to our will, for example. We can use these elements to make our phone vibrate or send data through a certain wire, and we need special elements to help do that. And one type of such elements that help us are the rare earth metals. Now, the rare earth metals include the lanthanides, as well as scandium and yttrium. And a single iPhone contains 8 different rare earth metals. You'll use these in your display, in your speaker, microphone, and it helps make your phone vibrate. In fact, rare earth elements are so important to electronics that the U.S. Department of Energy has referred to them as the technology metals. Basically, they're in everything. Next, we'll go over an overview of the certain parts of a cell phone that we use specific elements for. The 4 parts we're talking about are the screen, electronics, battery, and the casing. First, we'll talk about the batteries. Now, the majority of today's phones use lithium-ion batteries, and these batteries are held in generally aluminum casings. That's because aluminum doesn't conduct electricity as well as some other metals, therefore the battery energy is contained, it's not spreading everywhere throughout the phone. That would be bad. Next, we'll talk about the electronics. In terms of the chip, the actual processor of the phone, that's pure silicon. And that's why we get the name Silicon Valley, because silicon is so important to the development of pretty much every electronic, including cell phones. Silicon doesn't conduct electricity, though. It's only a semiconductor. It only conducts electricity if we do what is called doping to it. Now, that's basically when we bombard it with a different element. Now, that element can be phosphorus, antimony, gallium, arsenic, boron, or indium. There's a lot of different options, and each of them have their own benefits and disadvantages. So that's how we get the silicon to actually conduct electricity, and that's how we use it in the actual processor. In terms of the microelectrical components of the phone, the sort of wires, we use copper, gold, and silver, but tantalum can also be used, and we use tantalum mostly in microcapacitors, which are what store data and other assorted uses. Next, we'll talk about the casing of phones. Casing, depending on the quality of the phone you have, can either be metal or plastic. If it's plastic, then it's obviously carbon-based. But if it's metal, we can use generally magnesium alloys. In addition, there's a range of other elements we use in the sort of the micro wirings of phones, including platinum and palladium. Also, solder is generally lead-based. However, there's been a recent push to stop using lead-based materials because obviously lead's a poison, and instead we'll use a sort of combination of tin, silver, and copper, and that'll be used to help solder those micro wires together. Lastly, we'll talk about the screen. And I'm talking about the screen last because the screen is an enormously complex thing, part of your phone. It not only displays all the information your phone needs to tell you, but it also allows you to interact with your phone. It's a touchscreen, essentially. At least it is on most phones. And obviously, the screen being such an important part, we don't want the screen to break when we drop the phone. Now, if the screen was simply made of glass, that would happen every single time, and it would be really unfortunate. So what we use is a sort of glass ceramic mixture. And here, I'll get another picture for that. Glass is on this side, alright? Now, in glass, the molecules are not ordered in any kind of order. They're arranged more like a liquid, but they're like frozen in place. And this allows the atoms to sort of slip past each other, creating like atomic size cracks in the actual molecular structure. And if the crack is not fixed, then stress builds up and up and up, and eventually the screen breaks. The glass is, if we had used it as a screen. Ceramics, on the other hand, are much more ordered. They're crystalline. They're characterized by sort of ionic bonds between positive and negative ions, and they're much more structured. It's much harder for atoms to slip in past each other. This allows ceramics to be much, much stronger. However, for screens in our cell phones, we use neither of these. We use a combination of both, called a glass ceramic. Now, we get that by superheating glass to about 900 degrees Celsius. And we actually discovered this because of an accident. Some guy working at Corning, overheated his glass, and when he took it out, he dropped it, and instead of breaking, it bounced. And that's how we sort of discovered how we could use glass ceramics in a variety of capacities, including cell phones. In addition, Corning Glass has also created a new type of screen for the cell phones, and this is even stronger than a glass ceramic. They call it Gorilla Glass, and it's called so because it's extremely tough. It can withstand up to 100,000 pounds of pressure per square inch, which is a ton. And they are able to do this, they're able to achieve such toughness by not only using a glass ceramic, but by dipping it in a sort of molten bath of potassium. The potassium takes the place of sodium ions within the molecule, and potassium, being much larger, has to squeeze in to where the sodium used to be, and that sort of condenses the the space within it that it has, and that makes it a whole lot stronger. However, screens are not just for you to look at, they're also for you to touch. The type we have on cell phones are a little bit more accurate. Basically, there's an electrical current going through the screen at all times. It's not enough for you to feel, but when you touch it, your finger conducts that electricity based pretty much on the fact that your finger is coated in salt and oils that you can never really get rid of. And because you're conducting the electricity that's across the screen at pretty much all times, the location of where you touch it is calculated by the controller, and you get a much more accurate result. However, you're not able to touch anything to it. It has to be your finger. That's pretty much it for the chemistry of cell phones themselves. And I hope you enjoyed my video. It'll be the last one, hopefully I'll do. Thank you all for watching. I'm a player named Jeff.